Hey everybody, welcome back to the channel. In today's video, we're going to be sharpening this 3-flute drill bit, also sometimes known as a core drill. Now, we're all going to have different tools and machinery than each other, and we're all going to set out and do whatever it is we want to do with whatever it is we have, and that's just how it's going to be. So however you're going to do something like this, best of luck to you. I'm going to show you the ways that I have available of doing it, and then in the end, which way I'm going to choose to actually do it for this video. Now, if you're lucky enough to have a tool and cutter grinder, you could set this up between centers on your table and index using one of these spring-loaded fingers off of a toothpaste, and that would work fine. Probably not ideal, because generally speaking, this is a cammed relief on the cutting edge, behind the cutting edge of a drill bit, and you would be producing an angular relief by using the tailstocks. So doable, much more accurate than by hand, but wouldn't be my first choice. Now we'll add to that this has a nice center hole in one end, but has none in the other end, and so that wouldn't really work for us here anyways. Now you could, I suppose, if you had a lathe as well, you could put a center drill there, and again, you're going to do what you can with what you have, and it's all good. So moving on to the next method that we could use here, we could put it in a collet in a sensitive workhead, and then again use our spring-loaded pointer finger for the indexing. Now to do this, we'd have to hold it in a collet. This is a 5C collet chuck. I happen to have two different styles of 5C collets. I have the standard 5C, which has 3 segments to it. And then I have the special 5SC collets, which have 4 segments. And if you look quite closely, you can see this has a very long gripping area in this 5ST collet, as compared to the length of the gripping area in a standard 5C collet. So the length of the gripping area really adds to accuracy, especially when you're talking about something that only has quite small lands to grip on. If it was perfectly round, it really wouldn't make a whole lot of difference, but when you're gripping on such a small area, and that area is, you know, twisting away, the 5SD collet would give you much better results. Now, this is a 13/16 drill bit, which is close to 20.64 millimeters, and I do happen to have the appropriate size collet. But because it's the 5C collet, I just know that this thing wouldn't dial in very well in there, and so I'm not going to choose to use that. Now, over the years, anytime that I didn't have the higher quality 5ST collet, which are quite expensive, I would make these bushings just to adapt to the next closest size of the 5ST collet, and then put my oddball size bits in there. I don't happen to have a sleeve that goes to 13/16 on the ID, so I'm not going to be doing it that way. Having said all that, I think that got rambly. I'm going to be doing this in my tool and cutter grinder, and there's 3 main reasons for that. The first reason is I have a cam relieving fixture, and that's the preferred method of sharpening on this style of drill bit, and so that's reason number 1. The second reason is my cam relieving fixture has a tailstock with a center, and a center is one of the very most accurate ways to support a workpiece, and so that's going to work with our drill that has a center in one end only. The third reason is, since we don't have a center in this end, we're going to be holding this end in a collet, and it is the standard 5C collet, which again isn't accurate if you're holding lands on flutes and so on, but if you're holding a round diameter, it's just fine, and any little inaccuracy that may be in there isn't going to matter one bit, because it's so far from the actual cutting edge that's doing the work, and it's going to be mint. Those are the 3 reasons why I'm choosing to use this machine. There's actually a 4th reason why I'm using this method instead of the 2 other possible methods I showed you earlier, and that's because this is an awful lot funner.
Everybody likes spoon.
So let's talk about setup for a minute, and believe it or not, what probably looks like a big disorganized mess here is actually nearly a complete setup. And I want to get into why that is, what the various steps are, and some of the things that are important when you're setting up like this. You'll notice this machine is incredibly universal. It has a graduated, knuckle here with degrees on it. It's got another one down below that's going to be hard to see from here. The table swivels. The camera leaving fixture swivels. Everything goes up and down. The table goes back and forth. It goes in and out. There's just a huge range of travel. But even though there is all that travel, the last thing you want to do is start out by going crazy, dialing something in somewhere that's just bang on and spend all that time later to find out you don't have the travel somewhere. So my advice to you would be, when you start out with a setup like this, start out with the whole thing just loose. Don't even pull out your dial indicator. Don't pull out your height gauge. Just get every adjustable knuckle there is on this thing loose, and then start playing with it and seeing where things will go. Now, for my particular setup, one thing that was important was I wanted to be able to swivel one joint from the grinding position, where I'm actually grinding the tool, to the dressing position, and not have to change a million other things. And so I've gone ahead and dressed this, and now we're ready to swing it into the grinding position, where it's going to start working, where it can work on the tool. And then this whole thing is going to begin to start looking like something. I've rotated the grinding head into the position it's going to be for actually doing this job. And I think you can see it's all starting to sort of make a little more sense now, and starting to look like a bit more of a plan was laid out in advance. There are endless different ways I could have set this thing up on here. By far the easiest way would be to have the table straight, the camera leaving fixture straight with the table, the wheel dressed, to 90 degrees to the table, pivot the wheel to the angle I want to grind onto the drill, and then just start feeding into it. And the reason I'm not doing that, even though it would have been quick and easy, is I don't have a micrometer control over my length. There's a high range and a low range, but even with the low range, it's impossible to say, oh, I want to take half a thou. It's just, you have no control. It's a thou, 3 thou. So I don't want to use this axis to do this grinding. The in and out on this machine, the cross slide does have the micrometer feed, and so that's why I now have my camera leaving fixture dialed in 90 degrees to the length of travel of the table, so I can do my infeeding with my graduated hand wheel. Well, you might say, wouldn't it be easier to have the wheel dressed flat and the camera leaving fixture turned to the angle you want to grind, and then you could still use your micrometer hand wheel infeed? While that is true, because the center line of the tool would no longer be true to the center line of the cross feed, that as you ground down lengthwise into the tool, you'd be leaving this tapered nub behind that's supporting the center hole. And that would be very difficult to control, to keep it from not being tapered and choppy and ugly. And it'd be very unprofessional looking. And so I've decided not to do it that way. So what I am going to do is I've offset my wheel to the taper I want to grind on the drill, and the drill will be traveling straight in at the wheel, which will leave a nice cylindrical little nub behind, and it'll just be cleaner and look better. So I'm going to pop my reamer into this collet. I'm going to make it snuggish so it's not flopping, but I'm going to leave it loose because I'm going to need to rotate that as I go. Now I'm going to bring my tailstock up into it, and I'm not going to put any spring pressure on it for now. I'm just going to leave it there as a sort of, guide to help this further be centered as I go. If you look here, I have the 0 mark on the spindle of my camera leaving fixture aligned with the 0 on the fixture itself. And what that's telling me is that this is the point at which the camming action has stopped retracting from the grinding wheel, is starting to advance towards the grinding wheel again. And so when I'm at this position, I want my tooth face to be just below center height. And the reason for that is because as my tooth face passes up through center height, I want the camera leaving action to be in the positive direction so that I'm creating a relief. So I've got that set now, and I'm going to snug my collet up, not going crazy on it because I may choose to further adjust this. I'm at the point now where my zeros are lined up. My tooth face is just below 0. And at the same time, I have this dial, which is the axial travel reading dial, set to 0 so you guys can see what is happening. So as I pass the tooth face up past the center height, you can see this is showing a relief that's being created behind the cutting edge on the tool. Now right there, it started going back the other direction. And I'll show you why in a sec. So it's at this point in rotation where the dial has just stopped going positive and started going negative. That means it's no longer in the relief creating mode. It's in the returning mode to begin the next cycle. And what you can notice here is that the heel of the tooth behind the cutting edge has passed past center. So what that's telling me is it was below center to start with. So as it's passing center, a relief is being created. That relief continues to be created until the heel passes above center. And then by the time this thing pops out, the heel is out of the way. So we're gonna have a nice continuous relief the full length across that distance. I hope that makes sense. I'm not gonna be able to use a wheel guard today just because of the setup the belt guard's on, but I'm not gonna be able to use the wheel guard. However, that doesn't mean it's just caution to the wind. There's some real easy tips for staying safe when you don't have a wheel guard on. And the biggest one is never get in line with the radial disc that the grinding wheel creates. That's the danger zone. If for some reason this were to blow up, all the shrapnel is going to be in line with that disc. Now sure, it may go a ways and hit something and bounce off, and then there's some of that, but by then it's, you know, hit something and slowed down. The most dangerous place to be is in that disc. So throughout this process, I'm going to make sure I have as few body parts as possible in that disc, and especially the more important body parts are not going to be in that disc.
Like me?
Yeah, like you, the most important body part. We're all set up and ready to go here. We've got our drill bit timed properly with its flutes into our radial grinding fixture. Our wheel is dressed at the angle that we want to create on the end of this drill bit. Everything's in the right place, just a matter of firing everything up and getting this show on the road. So that's all finished up now. We've got a decent surface finish here. Of course, we know that all 3 of our tooth faces, our leading edges, are at exactly the same height, so that's good. We have a nice clearance here. Now it's hard to see here because there's a land, some relief, and then more relief, but here it's really easy to see the axial clearance in this little nub that's been left behind. Well, that's it for today's video, guys. I hope you enjoyed. We'll see you in the next one.